Welcome to Out-of-Band Stir Shaken and Introduction and Tutorial, our 28th monthly webinar covering technical, business, and partner topics to help service providers build better voice networks. As service providers work to address illegal robocalling and implement Stir Shaken, barriers have surfaced that limited their ability to participate or get into compliance. From dropped identity tokens in transit to incompatible TDM equipment and requiring expensive system upgrades, an alternative method is needed to accomplish the objectives laid out by the FCC and CRTC. During today's event, we are joined by the experts from TransNexus to describe Out-of-Band Shaken, an innovative new solution to implement Stir Shaken for both SIP and TDM service providers. So let's get started. First, some introductions. I'm Alan Percy, the CMO for Telco Bridges and today's event host, and glad to have you here join us with us. Along with our guest today is Jim Dalton. He's the CEO at TransNexus, and Jim is joining us from his home office outside Atlanta, Georgia. And Jim, thanks for sharing your expertise with us today.
Alan, it's great to be here. Thank you.
Glad to have you here. It's exciting. But before we get started, just a quick reminder that you can find the recordings of our past webinars, conference presentations, how-to videos, and a very popular online training sessions on our YouTube channel. Just head over to youtube.com/telcobridges and be sure to subscribe. All right, so let's take a peek at our agenda for today. We're going to start out with a quick poll question to see where you folks are along in your Stir Shaken journey. And welcome some of our guests from various organizations. We're going to move on and talk about a regulatory update, just get an update from Jim on what's happening on the regulatory front. We're going to just do a quick summary of what is Stir Shaken for those of you that maybe just need a little refresh, some of the issues with Stir Shaken, and then we're going to introduce the Out-of-Band Shaken solution, talk about why someone would want to do it, why the SIP and TDM providers might want to do it. And then we'll finish up with how to get started, and we'll finally get to your questions. So lots to cover today. All right, so let's push out our first poll question, which is, where are you along your Stir Shaken journey? So let me push this out. All right, so the results are 54% of you are researching, which is great. You're in the right spot. 17% planning. 9% are designing the solution, 8% are partially completed. We have nobody who's completed their implementation, and 12% that it's not applicable. So anyway, thanks everyone for responding to our poll question today. That was great, appreciate it. First, before we go on to, I want to welcome some of our guests. We've had some folks join us through from the Cloud Communications Alliance. The SIP School, a great resource for those of you that are coming up to speed on SIP and learning how to use it. They've helped us with promotion of today's event. Also to the NTCA, the Rural Broadband Association, thank you very much for inviting your members to the event. And of course, Jim, thanks for sharing the story about this event with your TransNexus database. So thanks again. All right, since there are so many new faces, I just wanted to include a slide or two about both Telco Bridges and TransNexus. And for those of you who aren't familiar with Telco Bridges, we're a manufacturer of VoIP media gateways and session border controller software for carriers. We're a privately held company founded in 2002. We've got roughly about 40 employees. Majority of them are in our headquarters, which is in Montreal, Canada. And that's where all the hardware and software development is done and all the production is done. And we have sales and support offices in Vancouver, Poland, Turkey, and Hong Kong. I manage our marketing out of Buffalo, New York, and we have 24/7 technical support that's provided, following the sun through our support offices. The portfolio for the company basically consists of two product lines, our signaling and media gateways, and a couple examples here. The TMG 800 is a very popular mid-density media gateway. Our 3200 is a high density, and a very high density TMG 7800 used in a lot of large service provider applications. We also offer virtualized session border controller software with our Pro SBC, and a set of professional services from our Pro SBC Pro Services group. With that, Jim, I'm going to turn to you and have you quick introduce TransNexus.
Great, thank you, Alan. So TransNexus, we got started in 1997, focused on the very beginning to provide security and routing solutions for voice over IP networks. And that's what we've always done. And our primary product is really it's a suite of solutions for really managing SIP trunking services, all aspects of the policies for managing SIP trunking, and so least cost routing and billing and things like that. But fraud prevention and robocall prevention are two natural add-ons when you make a route decision, to consider that kind of analysis as part of the routing decision. And stir and shaken is really, it's a perfect fit for what we do. So when our customers, they need, whether it's an inbound routing decision or outbound, that's a perfect opportunity for us at the same time to implement either a shaken authentication service to add a digitally signed token, or to verify an inbound call. And so that's what we are. That's TransNexus.
Great. Thanks for the intro. All right, so I'm going to start out with a question for you, Jim, which is what's new from the FCC and CRTC? I mean, this is constantly moving target, so maybe you could share with us a little bit of background.
Sure. So Canada's interesting. You know, Canada was very first out of the gate to mandate shaken, and that date has slipped some one time. And the latest decisions from the CRTC were actually in December, and they moved the shaken mandate for SIP networks out to the 30th of September of this year. And one thing that's important with those decisions is they established the Canadian Secure Token Governance Authority. And really that's the central body that acts as the trust anchor for Canada, whether it's the policy administrator or the certificate authority. That hadn't been completely decided how all that's going to be configured. But that was announced and approved by the CRTC, and they're really, we haven't seen a lot of movement, still a lot of planning, but I guess the key event that has not taken place has been the establishment of the policy administrator in Canada and certificate authorities for the shaken trust anchor. So we expect that's going to be coming soon, and we're waiting to hear that information. So it's kind of a wait and see right now in Canada for how they're going to move forward.
Great. And I know in a couple of slides you'll explain what the PA and the GA and the CA all are. So
yes,
hold that question. All right, from the FCC.
Yeah, so a lot going on in the U.S. So everybody's familiar, I'm sure, probably with the TRACE Act. That was a law passed by Congress at the end of last year that you have to implement shaken for SIP networks, and you have to provide call authentication for non-SIP networks. And it gave the FCC the ability to mandate those requirements, and they've done that with a report and order that came out at the end of March. And the report and order as it stands right now, it's fairly limited, but it's very clear. It applies to originating and terminating providers only. Is the original order, and it doesn't apply to intermediate providers. It does not, or transit providers, doesn't apply to gateway providers for calls originated abroad. That may happen, but it's not in the original order. So it's definitely for all SIP traffic between originating providers, terminating providers, they need to support shaken. And one thing that was kind of interesting, the second bullet point is you have to verify on-net calls. And it makes sense. I mean, if a call never leaves your network, you absolutely can verify the authenticity of that call. And that's an important part of it, because you want to be able to show your on-net providers that their calls have been verified just as well as an external call that you receive with the token. So that's the initial report and order that came out, that definitely we have to do it. Networks in the US are preparing for that. And, but there's still a lot of open issues. And let's chat about those, the next slide, Alan. Mm-hmm. And these open issues, we'll see what the FCC is going to do with this. Are they going to expand the report and order, the mandate for other aspects of the business? So one question is, should intermediate providers have to sign telephone calls? Do they need to implement shaken? And there are a couple of different ideas whether this should be or shouldn't be. You know, if the good part about every intermediate transit provider signing calls, it helps trace back. but at the same time, does it really add value? If they give it a low attestation, does it really help the end party recognize that it's a robocall or not? So there's an ongoing debate that needs to be decided if will Shaken apply to intermediate providers. Caller authentication for non-IP networks, that's TDM networks. That's a huge amount of traffic. Even though the world is moving to IP, there's a lot of non-IP network and end-to-end calls, and how that's going to be handled. And that is open up and for debate and discussion. And so many of the comments that have come to the FCC in response to this order. Call labeling is another a big open issue, a big battle about that. You know, can call labeling really be implemented in a way that you can count on? What's the intent of a telephone call? Should providers need to provide that kind of information about the intent of a phone call? Is it a survey call? Is it a spam call? Is it a, an election campaign call? Still an open issue. This fourth one, rules to access for numbering resources. Should that be modified? That's an important one. There may be some flexibility on that. Today, to be able to sign calls as a service provider, to be able to use Shaken digitally signed telephone calls, you need access to numbering resources in the US. You don't have to be a full CLEC, but there are some regulatory hurdles you have to cross. Should that be relaxed? There are a lot of enterprises and companies that support enterprises that use numbers from other carriers, buy DIDs from telephone companies. You know, we provide telephone service in every way. We should be able to sign our telephone calls. And that's an open issue that's still being considered by the FCC to perhaps relax the restrictions and allow more companies who today would be classified as enterprisers be able to have the same ability to sign calls as service providers. We'll see what happens. And then so many comments about burdens and barriers, the costs and benefits of Shaken in terms of comments, and deadline extensions. And so many comments about the board, across the board, should Shaken be extended? A lot of debate about whether that's fair or it's needed. And we'll talk a little bit more about that later, because deadline extensions, from a number of providers, especially for smaller operators, is really not a benefit. It really could be a bad situation to be excluded from the Shaken Trust Network. And we'll talk about that in some later slides. So a lot of open issues. I think they're going to be decided by the FCC in the coming months. And if anybody on the call has, opinions, concerns, you should submit an ex parte filing to the FCC. They're asking for input. So let's go on to the next slide, Alan. Sure. So, I want to point out, you mentioned that you included NTCA on this call, and a lot of small carriers out there serving a big chunk of North America, Canada, and the U.S. And this is a really big issue for small carriers, and it's just not small rural carriers. This also applies to CLECs in urban areas that count on receiving their calls from a TDM network, and their concern is they're going to be shut out from the Shaken Trust Network, and because they can't get access to the Shaken network because they don't have a SIP interconnect. And we're going to be talking more about this in the presentation, and it's a very serious concern, because if every network does not have equal access to the Shaken Trust Network, you start to have two networks. You have the big carriers that have the full trust infrastructure behind them that Shaken offers. You can trust those calls, that they're signed and authenticated. Everybody else, they're left out, and they have an inferior network. So it's an issue for subscribers. It's a competitive issue. And for smaller carriers, they're raising the issue. It's a reverse rural call completion issue. There used to be a concern you couldn't complete a telephone call to rural areas because they were getting blocked by larger carriers. Now there's a concern calls from rural carriers won't be completed because they can't be signed. And since they can't be signed, they're going to be considered spam and we be blocked by the analytics engines. So it's a serious concern. And, as mentioned here, time extensions for compliance, they don't help these problems. What small carriers need is they need same access, same benefits to the Shaken Trust Network as everybody else. And it's real simple. Small carriers just need SIP interconnects. It's as simple as that. That's what the FCC wants, what everybody wants. You know, if you can interconnect SIP, you can send a shaken token end to end. But the problem is, the practical reality is, so much of the world, you can't get a SIP interconnect to send outbound traffic or to receive inbound traffic. But that's the first need for small carriers, is to get that, you know, have the local tandem providers provide SIP interconnect. And if they can't provide that, then provide SIP interconnect for, you know, distant interconnect meet-me points, but not put all the burden, the cost burden, on the local carrier. You know, for the small operator in West Texas, it says, yeah, I'll be glad to interconnect with you over SIP, but you got to run a private line to Dallas. I mean, that could be over 500 miles. And that's a big burden to put on a small operator. That's a long way from an urban meet-me point for a SIP interconnect. And then the third point is, you know, if those two possibilities, you know, cannot happen, you can't have SIP everywhere, then out-of-band shaken is emerging as an alternative that can quickly, efficiently, at a low cost, enable shaken for everybody, regardless of their interconnect status. And that's really what this presentation is all about, and we'll get into that in more detail.
Good, good. Well, I'm going to move on to the next question, which is, can we start out with a quick summary of stir shaken before we get into the out-of-band stir or shaken? So I think if you want to just walk us through real quick how stir shaken was meant to work.
Yeah, so this is how it works, how it's meant to work, and how it's been deployed. And it's good to have just a review of this, because it's if you're not focused on these details every day, it's kind of hard to keep up with them. But this shaken trust anchor, it's a great thing. I mean, to be able to restore trust in the telephone network. You know, it feels like a regulatory burden. The FCC is putting, you know, another burden on us. But really, Alan, we see it's the biggest thing in voice communication since SIP. It really is going to be a great thing for service providers and their customers, because their customers are going to benefit so much. And it all begins with the governance authority. That's the box in the top left you see there. That's the group of directors, you know, big carriers, Microsoft, Google, as well as small trade organizations representing small carriers that come together, that set the policies that work for everybody. And those policies are administered through the policy administrator. That is iConnected that runs that. And they really enforce the rules that enable this public key infrastructure, this global security for the American telephone network to really work and be efficient. And the policy administrator does two things. Only telephone service providers can get into the ecosystem. So it's not just anybody. You've got to go through some, you know, regulatory vetting to be part of the telephone network ecosystem. And that's important. And what's important is they can toss somebody out immediately. So if anybody misbehaves, they're immediately yanked and they're out of the trust network. And the other piece that puts this together is, for this public key infrastructure, for this trust network, you need certificate authorities. And it can't just be any certificate authority. There are lots of certificate authorities. Anybody could be a certificate authority. But you have to be approved and vetted by the policy administrator to be able to issue a certificate for shaken signatures. And the PA approves, vets both of these bodies and can reject any one of them at any time. So if anybody misbehaves, they're out of the shaken trust ecosystem. So there's a real, all the incentives are in place for everyone to behave, and there's no place to hide. So if somebody misbehaves, it's easy to identify them quickly. And that's it's really a great setup. It's going to enable a lot of great new services for telephone service providers.
We got a great question right here in the middle here. Scott asks, how many certified CAs are there?
You know, right now I'm just aware of two. TransNexus is a CA, Newstar is a CA. It's open. Anybody, any company that goes through the process with the policy administrator to comply with their certificate of policies can be a CA. And it's designed that way that it's competitive. You know, if we misbehave, there are other people that, you know, there could be multiple other people that customers will have to be able to choose from to get a certificate.
Sure.
And yeah, there's nothing proprietary about a certificate. It's just it's a very open market sort of service that can be provided But the key is it's going to be just CAs that are approved by the policy administrator.
Good. Okay. All right, so now let's walk through this block diagram that shows them the originating carrier and terminating carrier with a calling and called party.
Yeah, so again, I know this is a review for a lot of people, but just make sure everybody understands. So the originating carrier here, they're going to be the one who signs the call. They run the shaken authentication module service, whatever it might be. And a call comes into their network from the calling party, and the switch or SBC is going to send a SIP invite to the shaken authentication software. And that's what's going to create the digitally signed passport token. That's the identity token that you can verify at the destination network to be certain that the calling and called numbers have not been tampered within the call. And if they had been, you could immediately trace back to where that call came from through an origination ID. So if we look at the next slide, that gives us, I think, an example of a passport token.
Yep.
And just if you haven't seen one of these, I mean, this is what it is, and it's pretty simple. I think that's one of the great things about Shaken. There's a lot of work to get this into the network, but overall, it's a very it's an elegant, simple design. And this is the token that everybody's working to have in their calls. And the top, the header just describes what this token is, what this passport token is, and the X5U line, that is that in blue, you see that's where the certificate repository is, where you go get the digital certificate to use to verify this token, to verify that the signature with this token is actually valid. And the payload gives you the critical information for the call. It gives you the calling number, gives you the call ed number, and the time when the call occurred. And you can verify that if the signature is good, you can verify, are these calling and called numbers, do they match the SIP invite my call? If they do, then you can be sure that the calling and called number and your call setup is valid, hadn't been spoofed. And there's some additional information in there, is that attestation value, A, B, or C. And what everybody wants is attestation A. That means the originating service provider, they know their customer, they know you can trust this telephone number, this is a good call. And that's what everyone, that's what everybody wants, how their calls to be presented. There are a couple of other levels. B would be, a case where it comes from a trusted trunk. You're not absolutely certain that telephone number is tied to the telephone that made the call, but it came from that trunk group. And then attestation C is you really know nothing about the source of that call, but at least you know where it got put onto the telephone network. And the last thing I'll just point out at the very bottom is you see that origination ID. I mean, that's important for folks that are going to enforce telecom laws. We've had great laws against, spammers, but no way to enforce them. This gives you a very quick way to identify the source of the bad call. From the certificate who signed it, you can go straight to that carrier and say, we've gotten a call complaint from this origination ID, and that points directly into their network, what was the source of that call was. So the trace back is nearly immediate, and that's the really key thing that makes enforcement possible and enforces the Shake and Trust network.
Good. Okay. So then moving on, then we're on the verification side. So now the tokens pass over to the destination. It routes through the the IP networks and ends up over at either the soft switch or the SBC or the terminating carrier. What happens over here?
Yeah, so that's exactly right. As you said, it gets to the destination, and it's kind of the reverse of authentication. You send a SIP message to the Shake and verification module, and it includes the SIP identity token that came across the network. And with the Shake and verification service, it goes and gets that certificate. You remember in the previous, when we looked at the token, you saw the certificate of where to get, or the URL of where to get the certificate. You get that certificate, and it looks like it's on every call in this diagram. It's not. You'll probably get it once a day and then cache it. And you use that certificate to verify the signature for that SIP invite. And if it's good, or if it's not good, whatever the case, you're going to respond to the soft switch or session border controller with the verification status. And the verification status is the numbers, it's validated, it's invalid, or it cannot be validated. And there's kind of a simplification here, but somewhere in this network, carriers are going to have call analytics. And the verification status is going to be a really important part of the call analytics to determine, do you want to answer this call or not on behalf or route this call to one of your subscribers.
Right. Good. Well, that was a great overview. I think it gives a quick high-level look, but I do know, since you and I have worked together in the past, we put together a webinar earlier in this process called Battling Robocallers, How STIR/SHAKEN Works. And we've got a recording of it out on our YouTube channel, and you can find that again at youtube.com/telcobridges. And, as before, I encourage you to subscribe to that. And not only will you get access to that recording, but all the others, plus any new events that come along. So this is a great place to kind of get caught up on it. So save that for after today's event, but that's a great resource. All right, so you've explained how STIR/SHAKEN works, and you've also chatted about some of the hindrances earlier. But what are some of the key issues with STIR/SHAKEN, and what are the problems here?
Yeah, so Alan, gosh, we implemented SHAKEN, actually at the end of 2017. It's pretty straightforward from a software development and implementation view, but integrating it to the network, that is the challenge. And, we found challenges all over the place with our early customers. We would return the token as the SHAKEN authentication module would to the soft switch of their SBC, and it cannot take the token. There's no way to take that token and get it into the outbound SIP invite. That changes with newer releases. That's making that possible, but it's companies are going to need to upgrade their switch to be able to get to a newer release that will be able to accept that token from an authentication service. So that's kind of the first place. If you look in kind of at the originating carrier, their token is blocked at the soft switch or SBC. We've seen that's been a common problem. And when the call gets put out onto the network, if the call is going SIP across the internet, then packet fragmentation is it's an issue. And where the SIP invite with the identity token is too large to put in one UDP packet. And so it's put in two different packets, and if it goes across the internet, the packets will get out of order and the call will fail at the destination soft switch. So it's a manageable problem. And, if you've got a private connection between two carriers, UDP, I think it's going to work. We've seen that, but if you're going across the internet, you definitely have got a challenge with packet fragmentation. And also there are issues with TDM networks in the middle, and we'll talk about that in some other slides.
Sure.
And then again, at the final, on the destination, will their soft switch be able to, or SBC be able to let the token in and passed up to the verification module to be verified? And the problem is real simple. Just so many of these soft switches and SBCs are back-to-back user agents, and they're not, they weren't built to pass SIP identity tokens. That's what the new SHAKEN header is, and they just block it. So those issues are very, very common, we found.
Yep. Well, fortunately, when you and I got together probably, a little over 2 years ago, first time, and we talked about solving, building these kinds of solutions, we took care of it in our SBC right away, and we were able to get our SBC working. But you're right, there's other brands of SBCs or there's soft switches that have not either been upgraded or the upgrades cost a lot, are very expensive. So, yep, those seem to be real world challenges that we've seen too.
Right. Yeah. Great point. That's a great example. Y'all made the changes to make it easy, but it's not native in every device.
Right.
So the next challenge, I mentioned this, is what if you have a PSTN interconnect and you're just out, there's no way you're going to pass the token. The gateway that connects to the PSTN is not going to pass the SHAKEN token in a TDM signal. Or even if you're connected to your transit provider by SIP, there's probably in the path to the destination somewhere a PSTN leg, and the token is going to be lost. So those are the big challenges for end-to-end SHAKEN, that you just don't have this ubiquitous SIP network, SIP interconnects everywhere that can pass these tokens.
Okay, interesting. All right, so she showed what is stir shaken. So what is out of band shaken, and how is it different from stir shaken? So let's just walk us through this.
Yeah. So, what out of band shaken is, it's building on an IETF standard called out of band stir that began a long time ago. And, we needed solutions for our customers. They had shaken, that was deployed, and it just worked in so few use cases because of all the issues we just talked about. And so, the solution we found in looking around trying to find some way to get this to work was to leverage this IETF standard called out of band stir. And really a more specific use case, which is out of band shaken, which is just, it's simpler than the standard of out of band stir. And what that is, it's sending the shaken identity token out of band directly from the authentication service to the verification service. It's really just that simple. So in the normal call flow, you've got this originating SBC. It goes to the shaken authentication goes to the shaken authentication module to get the digitally signed passport token and returns it to the soft switch to be passed in band. We added this new step where you can see the dashed arrow from the authentication module to the verification module in the destination network. At the same time, you've got an option to send that token directly peer-to-peer to the destination network's verification service. So out of band shaken doesn't replace in band shaken at all. It's a complement. It gives you a second chance to get that token to the destination network. So you can continue to do shaken in band like you'd always planned, and that's what we have here. A call will go end to end. But if that token doesn't pass through the public network, number 4, then it won't get to the soft switch to be passed up to the shaken verification service. But out of band shaken, like I said, it gives you a second chance, it gives you another way to get that token directly to the shaken verification module for verification. And actually, it can actually help with post-dial delay. And this is how. If you look at that, the dotted arrow, it goes straight from the shaken authentication module to the verification module. As soon as it arrives at the verification module, you can go ahead and get the certificate to validate that token. And if you have any kind of call analytics going on, if you're doing a CNAM dip, you can do all of those in advance before the call arrives. So if the out-of-band token arrives at the shaken verification before the call arrives in step 5, you can actually do those processes that are typically done after a call arrives. Get the certificate, do CNAM lookups, do your call authentics. All of that can be ready and waiting for the call before it gets to the verification service. Because the verification logic is identical, irregardless, or it doesn't matter how the token gets there. If it comes out of band or in band, the logic to validate that token and to verify that call by checking the calling and call number and timestamp is identical. And we first started this, we didn't know what to expect, and as we ran it in production with our network, with our customers, we found that it works very well, and it's very simple, and it's just a very, very cost-effective and efficient way to give you an option to get the token to the destination network in addition to sending it in band.
Excellent, interesting. I learned something today. There we go. Very good. So yeah, I guess then the status of this. This is obviously fairly new. So I think you gave a great overview.
So it is new. It's old and it's new. So like I say, it's based on out-of-band stir, and that first work began in 2013. So this idea has been kicked around for a long time in the IETF, and so it's not a brand new idea that we just dreamed up. It's something actually that the people in the IETF dreamed up a long time ago. And what we have done, and I don't mean we, but I mean people, our competitors are collaborating with this. What we have done is defined a specific use case of out-of-band stir that's out-of-band shaken. And that's important because it's much simpler than out-of-band stir. It's simpler to implement, and it's just the security issues are much simpler to deal with. And that's why we call it out-of-band shaken. It's definitely, it's a specific use case of out-of-band stir. It's not as general. And as I mentioned, it's TransNexus and two competitors, NetNumber and Newstar. The three of us have combined to move this technique forward in the ATIS IP&I working group to have it approved as a standard. It hadn't happened yet. It's been approved as a baseline document, and it's going through the process in the working group to, to totally vet the idea, raise all the issues, dream up every edge case that's possible. And the process is working. I mean, it's this standardization process. It's a great process because it gets so many eyeballs and critiques on a technique. And I think the good news is out-of-band shaking is actually a very simple technique of just passing that token out of band. So it's in terms of out-of-band shaking becoming a standard, you're going to hear it's not a standard. That's a fact. You'll hear some people don't like out-of-band shaking. They have their own reasons. And that's a fact. Out-of-band shaking is not a standard now. You'll hear it's brand new. I don't think that's quite true. I think this idea has been around for a while. But it's certainly new in terms of implementations. It's early days for out-of-band. It's early days for in-band shaking as well. So just want everybody to know that, you're going to hear stories that from folks that don't like out-of-band, that it's not real, it's not here. And there's definitely some truth to that. But what we have found is it's a great tool. It's not the only way to do things, but it's a great tool to solve a lot of problems. And it's so effective and so cost effective. We think it's likely going to be approved as a standard, but we're not there yet, but that's what we expect.
Interesting. Okay. All right. So our next question to them, why would a SIP service provider want to use out-of-band shaken? All right. A SIP service provider should be able to deliver an in-band token. Why would they want to use this out-of-band shaken?
There's a long list of things here that, are reasons why it's good. I mean, for me, it just boils down to it's simpler and gives you flexibility. It gives you, you're not going to lose tokens in transit, whether it's at your SBC, it's a terminating provider's SBC, whether it's a switch in a transit network. If you've got TDM interconnects, so many of our customers do, they're all SIP, CLEX or ILEX. But they have to get their calls from their local tandem. It's the only way they can get inbound calls to their numbers. How do they get a shaken token? It's their only option really to be able to participate in the shaken ecosystem. And, it's nice because it gives the telephone service provider some independence, some choices of how they can comply with the trace stack more quickly, as opposed to upgrading their switch, upgrading all their SIP interconnects, or TDM interconnects, changing them to SIP. So it's the speed, the simplicity, the cost effectiveness all make good reasons. Even if you're a completely SIP infrastructure network, it can be helpful to what you're deploying. And, the bottom list there, it works on SIP networks, it works for TDM networks, it works on a hybrid.
Very good. Interesting. So now let's move on and talk about the TDM providers, right? We know there's still plenty of providers out there of TDM equipment, or some part of their network is still TDM. And how can they leverage this out-of-band shaken?
Yeah, so this is really interesting, and so this is a technique that really you guys developed, and we had customers, and they didn't have SIP, they didn't have a SIP interface to their switch, right. And we couldn't help them, but y'all offered a solution using your gateway, and realized an ISIP IM message is basically the same as a SIP invite. And, our software, we need a SIP invite. That's what the shaken standard defines as, as the interface to a shaken authentication and verification module. And, what y'all devised is, let's just take an ISIP message. We'll convert it into SIP that, you need for shaken authentication. We're going to pull out, we got the calling number, we got the called number, we've got the timestamp, we got everything from the ISIP message that we need to use. The shaken authentication module can add the attestation based on the customer's policies. It can add that origination ID based on the customer's policies, and it can sign it. And now you got a token, and we can send it out of band to the destination. And you return a release, a cause code that tells the TDM switch to route advance. So the TDM switch configuration is simple. The shaken authentication module looks like the first outbound trunk, and you set up as local routing in that. Of course, it never routes a call anywhere, But if it's a good call it's been authenticated, it returns a code 34 that tells the switch to route advance, and the token gets sent outbound. And it's also possible if the originating service side of the TDM switch, if he wants to be able to block calls for certain customers because they shouldn't be authenticated, he can do that with his authentication module as well, which will indicate back to the gateway not to return a cause code 34, to return a cause code 21. So it could be a way to use some analytics to, block calls to make sure your originating customers are using the DIDs allocated to them at the source side. And then on the destination side, it's the same setup. And, when a call comes to the TDM, the first route before it goes to the subscriber is send it to the verification service through the telco bridges gateway. Repeats the same process. For us, we don't know the difference between a SIP soft switch or a telco bridges gateway. It's all just a SIP invite. And it would be the same for any shaken application, not just TransNexus. That's the beauty of this. It's all standards based, and you can pick and choose. You could use somebody else's platform if you wanted to, and they wouldn't know the difference. And again, it's the same thing. You return a cause code back 34 that the call's been verified, looks good. And if it hadn't been verified, you could return a cause code 21 to indicate, this customer does not want bad calls, that have not been called or have invalid calling number. They can be blocked. So this is a great thing, because the alternative for these providers, they just don't have a practical alternative for them to upgrade their switch to get SIP interconnects. They are completely cut out of the shaken ecosystem. There really is no solution for them now. And this gives them an alternative. And it's a great technique, and it's been working just fine. It's a great idea.
Yeah, no, it's been, it's really been a game changer for a number of customers. So it's really worked out. It's been a great 1-2 punch. So, all right. So, we're getting all kinds of feedback from service providers. You've obviously collected quite a bit of it from a wide range of service providers on out-of-band shaken. So you collected a lot of it and threw it together here on a slide here. So I'm curious just to walk us through these people.
This is a variety of telephone companies that, have said, yeah, you can use our logo to just say, let people know that we're using shaken out of band, to try to identify robocalls. And, the number of shaken calls today is still pretty early, but it's early. So there are not a lot of calls with SIP identity tokens. But one thing these people do have checked off is they are Trace Act compliant, which they like to be able to say, this is the DFE of operations. He knows I've got that done. I'm taken care of. I've complied. I can work on other things for the rest of this year. And as shaken, as there's more penetration and tokens are passed in band or as out of band catches on, these people will, be early benefiters of what's working for them. And you can see from the comments there, it's just the implementation, given the option of going out of band, it really makes the implementation much simpler. And, we just need more people to implement shaken so we can, ensure that the calling number hadn't been spoofed and have better robocall protection. Great.
That's awesome. Glad to hear all that. Fantastic. So let's talk about some coming attractions. I think we put together a list of things that are maybe just around the corner.
Yeah, gosh, we won't have time to get into this right now, but, as I said at the very beginning, and this shaken is not a regulatory burden. It's a big opportunity. It really is for service providers and your customers. You're going to be able to develop innovative new services your customers are going to love starting next year and later years. So out-of-band shaken, as I mentioned, it's progressing towards adoption. We think it's going to, it's going to be widely deployed. Addis, that's the organization that defines these frameworks such as shaken. They've started a new working group for TDM call authentication, and it's just beginning, has its first meeting next week. I think this is a great thing. I mean, TDM is, we want an all IP network. We want all SIP. Everybody wants it, but, it just isn't going to happen right away. And here is a, this is a working group that's going to be focused on call authentication for TDM networks. I think it'll tie into out-of-band beautifully as well. And I think that's a great initiative. So if anybody is welcome, they would love to have new participants involved. They want to hear ideas. They want to hear contributions. So if anybody's interested, they should contact us about that. Call forwarding for 8YY calls. The Shaken implementation, that's being finalized, and that's going to cover basically just about the remaining call flows for Shaken. And I guess the big one that's just going to be available next year is really rich call data. That's where we can provide a lot more information. You know, a picture, a logo, a reason for a call, all of it signed by the originating service provider, so you can really trust the telephone call. Who is calling me? Why are they calling? Enterprises love this feature because their call completion rates are going to go way up. And then the last point is delegated certificates. Gives the ability for enterprises to be able to sign their own calls because they've gotten a certificate delegated from their service provider. So that technique is emerging to be provided.
Great, good stuff. I think we are well on our way. So, of course, the next question is how to get started, right? And this is one of the hurdles. There's a lot here to absorb, and the question usually pops up with how to get started. So Jim and I put together a call to action here, which for you folks is we'd like to invite you to request a consultation. You know, every network's a little different, every situation's a little different, and the best thing to do is to get together on a conference call. And starting with guiding you through the process of working through the PA registration. That's the first step. Looking through your network and your network configuration, what your individual situation is. And then Jim's offering a free trial with 1 million call processing. I guess the best way to put it, you're going to process 1 million calls as part of a proof of concept.
Yes.
And we're going to offer a free 90-day Pro SBC subscription as part of that bundle to give you a chance to stand up your POC to get a chance to see it work in action. And to request a consultation, it's real easy. Go to www.telcobridges.com/getshaken with a capital G and capital Shaken. Lowercase e and t, and of course we'll put that link in the follow-up email that you're going to get probably tomorrow. So watch for that and click on it, and just quick fill the form out, and then that'll get you. We'll set you up with a call with Jim's team and our team to take a look at your particular situation. All right, so that brings us to the end of the content, and we can start to look at this huge pile of questions here, Jim. I warned you. You ready?
Yes, I think I spoke too long. We may need to. Hope we can answer.
Yeah. Well, we got about 10 minutes. We'll go, and then we can keep chipping away here. So I'm going to start at the top here. So Jason asks questions about can TransNexus and Telco Bridges products be used in the same server, and what server do you recommend? Both of our products are virtualized. So if they were to run within the service provider, they certainly could be virtualized on the same server, like a virtualized environment. However, Clear IP you offer as a service. Maybe just want to quick explain that.
Yeah, that's right. So the 1 million call trial, that's based on our cloud-based solution. So obviously there's no server. We do have an on-premises based solution, just like Alan said, it can run on a virtual machine. Right. So it could be the same infrastructure.
Yep. And if someone wanted to use our Amazon AWI as part of their POC, that certainly is a real good way to get started. So not have to stand up a server at all. So that makes life even easier. Scott asked a question. He said, what about SIP interconnects? And he's kind of inquiring about, can the intermediary sign the calls on behalf of the rural provider?
Yes. Yeah. Okay. I think they can. I guess just an issue you need to ask your intermediate provider, will they give you attestation A? So they definitely can, and they can sign your calls with attestation A. And you just want to make sure they're going to do that for you, and it's a cost-effective service.
Right. And Hai asks a question. He says, the GA, is that the FCC, for example? And the answer is no. And so maybe Jimmy could explain the role of ATIS in this whole thing.
Yeah. So the GA, it's I think there are 12 members on the board running from AT&T to the NTCA. So it covers really the spectrum of telephone service providers in those 12 board members. And they're the governing body that, make the policy decisions, and the FCC certainly must have some kind of input, but they're the ones that call the shots. And it's an industry-led group and decision-making process under the guidance of the FCC.
Right. So the GA is not the Federal Communications Commission. For example, it's not the CRTC up in Canada. It's a standalone, separate body. All right. So Stephen asked a question: what happens to a user, or I'm guessing a provider, a service provider that has a certificate? Of course, it acquired from a certificate authority, and they violate and they lose their certificate. What happens? And we'll kind of walk through the termination of a certificate.
So you won't lose your certificate. Your certificate will be public. It'll be out there in the certificate repositories for everybody to get. So you won't lose your public certificate, but you could have your private key compromised, and you would need to report that immediately to the CA, your CA, and to the PA, and go through the process to have that certificate revoked. And what we do is we issue short-lived certificates. We think that's the best practice. We issue 24-hour certificates. For that reason, what if your certificate was compromised and now somebody's got your certificate? They're going to sign calls with your signature, probably not for robocalls, probably for high-value criminal calls. And you may not know about it because they're not going to make a lot of calls. They're just going to be high-value calls where they want to spoof a calling number that, it's using your signature. Mm-hmm. So that's why we think short-lived certificates are the best. And, when it occurs, you want to get it revoked as quickly as possible.
So what happens in the system when a certificate is revoked, though? From a practical standpoint, the SBC, does it redirect the call? Does it drop it? What would typically a service provider do with it?
So once the certificate is revoked, anybody that uses that private key to sign a passport, you'll see that the passport's invalid. Mm-hmm. So, that private key, all those digital certificates with that private key for that revoked digital certificate will never be validated.
Got it. Okay. So the worst comes to worst, the call is just not validated. And then at that point, it's up to the service provider to make a decision about, when it goes through the validation process, what to do with the call. They could choose to not forward it on to the subscriber. They could send it off to, a pre-recorded message. There's all kinds of things that they could do.
Yeah, so just a clarification, it's not that the call is not verified. It's going to be invalid.
Right.
And that's not a good situation. So that's why you want to revoke the certificate and get it removed and replaced as soon as possible.
Got it. Okay. All right. Kevin asked the question, is there any common response to an invite without a token, which obviously happens to a lot of calls now, because, there's not a lot of actual live traffic with identity tokens. So what are the providers really doing with the calls that don't have a token?
Yeah, right now there's no one would block a call today without a token, because you said, that's the vast majority. So we are a long way from evolving to a situation where there are enough signed calls that you may make an exception to a call that's not signed.
And matter of fact, in our talking with some of the fraud protection companies at the enterprise level, they're looking forward to seeing these identity tokens, or the VERSTAT essentially is what they're looking forward to seeing as quickly as possible. And what that does, it gives them assurance that at least they know the number's not being spoofed. So at least that's one check mark on their long list of things that they're looking for. But you're right, not having it today is the majority of the traffic. Let's say, so a question about international is, I asked a question about, stir shaken for operators outside the US and Canada. And have you seen any evidence of any uptake outside North America?
No, we get We get questions occasionally from different regulators around the world, Middle East, Far East, Europe, kind of trying to learn more about shaking. But I think given how they're years away, it's a hard thing to get everybody on board.
Right, right. Okay. Let's see. So a question comes about, if the token arrives too late, right? So the call arrives, let's say a call arrives through the normal means, but doesn't have a token on it, and it arrives, and then you wait, let's say, I don't know, what, a second or so to see if the token comes out of band, and it doesn't arrive, then it's the same as just not having a token, right? At that point.
Exactly.
Yep. Okay. All right. Let's see. Mechanism. Let's see. Let's skip over. A couple of these are repeats here. So, oh yeah. So yes, Bob asked the question. It says, can we assume that the out-of-band shaken only works if both the originating and terminating service provider has soft switch or SBC? So what about that hybrid situation? What if there was an IP soft switch in one provider and a TDM provider on the other end of the call? Which we didn't show in a block diagram, but it's a good question.
Yeah, it absolutely will work. So we showed kind of the worst case where both sides were TDM, but if one side is SIP and one side is TDM, it's still the same. Out of band will work in all those use cases.
Right, right. So kind of a hybrid. Why? Steve asked the questions. Why are Tier 1 friends, AT&T or Verizon, are not supportive of out-of-band shaking? It baffles him. So he's probably not the only one it baffles. So keep going.
I don't know. It's you have to talk to them. I'm not sure what their reasons are. I think the big thing that, it's not an approved standard at Addis. I think that's their first concern. Right. I think when that process is completed, they'll feel differently, but I think that's that's a logical position to take. Until it's fully vetted, it's approved by Addis. We just can't consider it.
Good.
And so you need to ask them, but I think that could be part of their thinking.
Okay. So I'm noting here, I do see it is top of the hour. I know a lot of you folks probably have to go off to another meeting. Where'd you go? And there's a lot more questions here, so we're going to keep going with the questions. You can check back into the recording when we publish it tomorrow, and fast forward to the 1 hour mark, and then you can hear the rest of the Q&A if you're interested. But we're going to keep plugging away here because we still have another dozen or two questions to go. So appreciate everyone listening in. All right, so I could have predicted we were going to get this question, which is, how does the originating service provider know where to send the token? And this is the $20 question that we talked about before this webinar.
Yeah, that's such a great question. And that's part of the discussion at the IP&I working group. How do you discover the CPS? And so there are a couple of ideas on the table. One is the PA could distribute that information. The PA already has, it knows every service provider, it knows their OCNs, and you could easily add to that table the IP address of their verification service. So you could route it directly there. That's a way. It could be done. Will that be done? I don't know. There's another way. It's certainly plausible where the certificate authorities, they're already vetted by the PA, they're a trusted source. They could distribute that information for their service providers. They issue a certificate. They could be a trusted source to distribute the list of CPS for their certificate customers. That's a different alternative. I think how you're going to see it start is I would expect those three competitors, including us, will probably collaborate to do something that works right out of the gate to make it happen until it's the final solution is standardized. But what I've told you are a couple of ideas for the standards process.
Sure. Good. All right. Joe asked the question: any customers in production? And I think of that pool you talked earlier, you might want to share that story.
Yeah, so there are customers that are exchanging tokens out of band. As you saw that list, most of them are they don't have big footprints, so there's not a lot of calls between those networks that are getting out-of-band tokens. But when you do make a call between those networks, there will be a token that'll be passed out of band between those networks using the service that we provide that enables that. And when the other companies support out of band and receiving those tokens on behalf of their customers, we'll exchange them with those other AS and VS providers as well. So it'll be beyond just the TransNexus set of customers today.
Got it. Good. So Kevin asked a question. I'm going to adjust it a little bit because a couple of them here that are similar to it. But basically, you get information from the soft switch, incoming call from the switch. How can you know that the call coming into the soft switch can be trusted? And I think, yeah, that's a tough one because the service provider basically has to know their customers. You may want to just talk real quick about, knowing your customer question or problem.
Okay, yeah. So a couple of, certainly everything's in a private network. So within the service provider, I think there's implicit trust. If it's within your private network, you can trust all the calls, even on net from one of your subscribers to one of your subscribers. But there is this does raise the point that I guess that you just mentioned. You need to police the calling numbers your customers populate in their SIP invites. And I think that's something that's not done too widely today, but if you've given a customer 10 telephone numbers, they should only use those 10 telephone numbers unless you have given them permission to use a number that's not been allocated to them. So that really needs to be a policy that everybody enforces in their soft switch.
Right. Okay. Let's see. A couple of repeats here, so I'm skipping by here. So let's see. What specific device does need? What specific device? I think we kind of answered that. What specific devices need to be installed? It's a combination of that validation and authentication service, whether they be on the customer's prem or in the cloud, and either an SBC or media gateway to provide connectivity. So let's see. There's another question here. The originating service provider can ultimately sign any originating number. Therefore, there's a possibility to call spoof. This you just mentioned. You just answered this, right? The call can be spoofed. It's a matter of that the soft switch in the originating service provider, he's validating. Oh, so here's another question. What kind of costs are there involved, right? So this is from a gateway and SBC standpoint, it's their standard product. There's no additional charge to handle the integrations into the, for example, into GIM software. Maybe we just want to quickly talk your pricing model.
Yeah, so our pricing model for our cloud solution, we charge per call per month. So we add up the number of calls that you authenticate and you verify in a month using our cloud service and bill that way. And on-premise is priced a little bit differently. We give you a license based on busy hour call attempts, and that just measures, how quickly the software will authenticate and verify tokens.
Right. So Mitchell asked a question, but I'm going to adjust your question slightly, which is, the temporarily spoofing. And there are valid situations where people do, from a valid perspective, legally can spoof calls. And maybe it's worth mentioning just a couple of those use cases. For example, mass notification services that send out reminder phone calls. And for example, I know our school district does it. I know that our police department does it. They use those reverse 911 kind of applications to tell about, power outages and school closures and things like that. So maybe just quick, Jim, can you just talk about just how StirShaken handles those delegated or authenticated use of spoofing?
Yeah, so I think the simplest way is, what you're going to see most often is a service provider serving an enterprise that's making those calls. It could be a call center making the notification calls. They, like you brought the key term, they need to know their customer. They need that you're going to make these calls on the behalf of the American Red Cross or whoever it might be, and you're going to use their calling number. It's not one of our numbers. It's not one of, that's a number in another state, but it's okay. We've gone through the process. You have permission to use that calling number. That's what they want because they want to get the call back to that telephone number. So if you go through the process and you know your customer, it's a legitimate use to spoof the calling number, You can sign any calling number you want as a service provider, and that's absolutely part of the Shaken framework, gives you the ability to do that. You just need to make sure, I'm going to give this number an attestation of A because I've vetted my customer. They have the right to use this number, and I'm going to sign it A. So that's how that process is handled.
Yep. Good. Yeah. So a couple of questions, very similar to each other, is about like find me, follow me, and PBX kind of function. So a call, we kind of play the scenario out where a call arrives at an enterprise that got their own PBX or UC platform. It has a find me, follow me function in it. So the call arrives, it was validated, has a verse stat of yes, arrives at the UC platform. Now the UC platform turns around and forwards that call off to a cell phone. In that case, because it's making an outbound call, the call is going to have the calling number of the trunk that it goes out on, not necessarily the original called number, because that would require replacing it. So we're talking about basically reusing calling the called number, yes, from an external number, and basically that's just not going to be possible from the process you've walked through so far.
Yeah, that's a great question. I think that's worth another webinar. And really, that's a great question. Everybody needs to know because it's an important use case. It's a little bit of complicated call flow, and we need to really walk through and explain how, how Shaken for diversion calls is implemented. Same for 8YY. And but that's more than we can get into now, but a great question, and it's great that those use cases have been solved.
Maybe by that webinar, I'll be able to actually ask the question correctly. Who knows? So, all right, just a couple more here. Let's see. The implementation of verification server checks the authentication of the original service provider to sign given number other than validate GWT. Your implementation verify certificate path using X509 cert path check procedure. It's a good question. I don't even know what he's asking, so maybe you do, Jim. So implementation of verification service check the authority of the originating service provider to sign given number other than validate.
Yeah, so you need to make, I guess the question is, here's a certificate and it's been used to sign this call. Okay, I can use that certificate to verify that, but is that, who the heck is this certificate? So that has to that has to be a certificate that has been approved, that's been issued by a certificate authority approved by the policy administrator. So the policy administrator publishes the root certificates of the CAs that it has approved. So that needs to be part of your verification process, not just to validate that the signature you get in the certificate repository will definitely validate the signature, but it's been a certificate issued by a Shaken, a PA approved Shaken CA.
Yep, good. Okay, that's the end of the list. Thank you, Jim, for being patient, sticking around and answering all those questions. And for you 146 people who stuck around, I tip my chapeau. First of all, I want to thank Jim very much for providing your expertise to our audience and spending the time with us today. I know it was a scramble trying to get this all together, and appreciate your work and making it happen. And as we noted in the opening housekeeping, you're going to receive an email tomorrow with links to the slides, including a recording of today's event. Be sure to share this content with others in your professional network who would find it useful. And Jim, one more time, thanks again. And that's it from here. Wishing you all a great day.
Great. Thank you, Alan.